Hello, welcome to Quantum Online Academy. This is your Dr. Nagaraju Pendam. In this video, we are going to discuss about one more important quantum mechanics question. How we have to discuss this one, you able to see. So, till now we are discussing about the orbital angular momentum questions we are discussing. The subsequent topic of orbital angular momentum is spin angular momentum. The spin angular momentum in 1925, Uhlenbeck and Gaudsmit introduced the intrinsic angular momentum. That intrinsic angular momentum we call it as a spin angular momentum. The experimentally Stern and Gerlach in 1922 confirmed the spinning of a quantization of the atoms. So, he confirmed. So, based on that, Uhlenbeck and Gaudsmit in 1925 they introduced the spin angular momentum. Clear? So, this is the general introduction about the spin angular momentum. How we will get the questions in our competitive examination based on the spin angular momentum, once we will see in this video. This question was asked in CSIR December 2015. This question was asked. Once you have to read the question. The Hamiltonian for a spin of particle. The Hamiltonian for a spin of particle at rest is given by. So, what is the Hamiltonian? This Hamiltonian operator they are giving E0 into sigma z. So, E0 into sigma z plus alpha into sigma x. So, what they are giving? Alpha into sigma x they are giving the value. So, this is the Hamiltonian. H cap is equal to E0 into sigma z alpha into sigma x, where sigma x and sigma z are Pauli spin matrices. What are the sigma x matrix is equal to? What is the sigma matrix? 0 1 1 0. So, this is the sigma x matrix of the Pauli spin matrix. Sigma z is equal to 1 0 0 minus 1. This is the sigma z matrix 1 0 0 minus 1. Alpha is the constant. E0 and alpha are the constant. What we need to calculate? We have to calculate eigenvalue of what? Eigenvalue of the Hamiltonian matrix we need to calculate. How we able to calculate this one? Once you have to see. To solve this, H is equal to, first you have to substitute the matrix, you make it as a one matrix, you have to make E0 into sigma z plus alpha into sigma x, correct? You have to substitute the matrix E0 into, what is your sigma z? Your sigma z is equal to 1 0 0 minus 1. This is the Pauli sigma z matrix. Alpha into your sigma x is equal to 0 1 1 0 is your sigma x matrix is there. So, therefore, you have to write it is E0 into, so you have to take the matrix, you have to add this matrix, what is going to happen? So, 1 plus 0 is equal to 1, 1 plus alpha is equal to alpha, 0 plus alpha is equal to alpha. So, minus 1 plus 0 is equal to minus 1, you are going to get it. This is 1 alpha, alpha minus 1, which is equal to, that is the Hamiltonian operator matrix is equal. Suppose if you want to calculate the eigenvalue of this matrix, if lambda is eigenvalue, you have to take lambda is eigenvalue, you have to consider eigenvalue of what? Eigenvalue of H you have to consider. So, therefore, what we have to write it is the eigenvalue equation is, so what is your eigenvalue equation? The eigenvalue equation is, suppose you have to take the eigenvalue equation, H minus lambda I is equal to 0. This is the characteristic equation or eigenvalue equation. So, based on that eigenvalue equation, first you have to calculate the matrix eigenvalue, how to calculate. So, modulus of 1 minus lambda alpha, you have to take alpha minus you have to take it as a 1 plus lambda which is equal to 0. So therefore minus of 1 minus lambda into 1 plus lambda minus alpha square is equal to 0. So you have to write it as minus 1 plus lambda square is equal to alpha square. So therefore lambda square is equal to 1 plus alpha square. Lambda is equal to square root of plus or minus 1 plus alpha square. This is the eigen value of that matrix. So therefore we need to write it as a eigen value of H cap is equal to eigen value of this Hamiltonian is equal to E0 into, we have to write it is plus or minus of square root of 1 plus alpha square. So therefore the eigen value of H cap is equal to plus or minus E0 into square root of 1 plus alpha square. This is your answer. Which one it is? Eigen value of Hamiltonian operate. Like this we have to calculate in our competitive examination. Once you have to see the options, so the first option is fitting plus or minus E naught into square root of 1 plus alpha square. The second option is not correct. The third option is not correct. The fourth option also not correct. Clear? So already I am informing you daily we started the CSIR and GATE physics online coaching we started. Clear? So in this JL and DL also is recorded classes are available. So once you have to like my teaching, you have to listen. More than 200 videos are there for physics classes only, maybe mathematical, classical, electromagnetic theory. Now I am uploading quantum mechanics classes I am uploading on YouTube channel. So you listen our classes. So maybe in the solution techniques only I am giving to you in YouTube channel, but all theory I taught in our app. Our app is Quantum Online Academy app. This is our symbol. Go to the Play Store in your Android mobile phone, download our app. After downloading our app, you have to call to me. My number is 9908437460. You have to negotiate with me to take the class also. Not only that, so your courses will appear like this: CSIR and GATE physics, JL physics and DL physics, like this courses will appear. Clear? So now we completed till now mathematical methods of physics we finish. Recorded classes are available. The latter we are finishing the classical mechanics, we are finishing. All recorded classes are available as per the CSIR syllabus. Now you have to take so electromagnetic theory, this individual paper also we are finishing. This is the third one. The fourth one is quantum mechanics we are teaching now. So more than half of the quantum mechanics syllabus also we finished. So now under spin angular momentum, already orbital angular momentum we finished. If we finish two topics, one is approximation method, that is perturbation theory, variational method, WKB approximation and identical particles. Those two particles are left behind. If two parts are completed, the core syllabus of the quantum mechanics is going to be finished. Clear? So if you really likes my teaching, you have to take this app, you have to purchase this app and get success in your competitive examination. Anyhow, please share and subscribe and like our YouTube channel and touch the bell button. Thank you so much. We will meet with another new video. Thank you.